Hello everyone. So today we are going to see GFGPOD and the problem is search in rotated sorted array. So we are given here a sorted array but it is rotated. Like from 1 to 3 this part should be our first part, then 5, 6, 7, 8, 9 should come, but it is rotated from here and the first part came at the last. So how we can determine it is rotated? So an array which is having smallest value and then it is going to a largest value, and again after that we are getting a small value and it is in increasing order. So this is a rotated sorted array. Otherwise we can have rotated sorted array with zero rotation, means just the sorted. That can also be a rotated sorted array, but that is with zero rotation. And here we have done three rotation. That's why our first three value came to the last. And yeah, similarly, all these values are also happening in the another arrays. So let's analyze what we have to do here. So we are having a rotated sorted array and a key given. So we have to find out the key where we have to find out the index of the key where key is present in our rotated sorted array. If it is not present in our rotated sorted array, then we have to return -1. So this problem is expected to solve in time complexity of big O of log n, and its expected auxiliary space is big O of 1. Constraints given here are the array size can vary from 1 to 10 to the power 6. The array value can vary from 0 to 10 to the power 6, and the key value can vary from 1 to 10 to the power 5. So here it is given 10 to the power 6. We can apply linear search to get the value because big O of n can give us answer, but expected time complexity is log n. We have to solve it in log n. So instead of linear search, we will apply binary search. Even though we can return the correct answer on linear search, we will try the binary search approach. So we use binary search in sorted array, right? But here we are having rotated sorted array, which represents like we don't have all the elements sorted in the array. So how we will apply the binary search in this problem? So ultimately we can search in this also by using some tricks inside binary search. So we will check all this intuition and the solution simultaneously while coding. I will explain all this intuition and the thing. Okay, so let's go with the code and I will explain the intuition as well. So here firstly we are going to take a left pointer which will be residing at the index 0, and a right pointer which will be at array dot length -1, means at the last position, last index, right? And then we will apply binary search, which is left should be always less than or equal to right. Until this condition is correct, we will do while loop, and inside that we will check our mid value. After that, we will check if array of mid value is equal to our key, then we will just return the value of index, means the mid value. Otherwise, we have the intuition right now. So if our value is not in the mid position, then we are going to check for the right part and the left part. And here is the main intuition. So let's understand this with the first example. So here our example is given, and the mid value inside this will be this one, 9. At the mid position 9 is present. So we will check whether our left part is sorted or not. If it is sorted, then only we will check the value inside this, and this will be our search space. So basically, we are checking for our left part and right part, whether the left part is sorted or not, and right part is sorted or not. And here, one thing is there. If left part is sorted, then for sure right part is not sorted. And if right part is sorted, then left part will not be sorted. This is for sure. Then our search space should be a sorted subarray only. So we will check for that. So for checking whether our given search space is sorted or not, so for that we will do if array of mid is greater than or equal to array of left, then only it means that it is sorted. The left part is sorted. Here 9 is greater than the left value means 5. Then it means all the values will be in increasing order here. So this part should be can be a search space. So here we will check two conditions. Okay, before going for that, we will here make another condition. If it is not sorted, then obviously the right part is sorted, and we have to check our search space can be the right part only. We should not consider the left part then. So inside that, now we are going inside. Let's suppose the left part is sorted, and inside that, we will check whether our key is present or not. If our key is present in the left part, then for sure our search space is the left part. We should for sure discard these ranges. We will not get any value in this range if our value is present in this range. In that case, we will decrement our value of right pointer to mid minus 1, and left will be at the same position, and this will be our search space. So we will go with that. So here we will make if array of mid is greater than our key and key is greater than or equal to array of left, then it means that our key is lying in this left region only, and our search space is is completely this part only, and we have to discard the right part totally. So for discarding the right part, we will make sure that our right pointer is in mid minus 1. Why mid minus 1, not just mid? Because we have already checked mid part, mid value. If it was it if it was the value, then it would have returned the value, right? It would not come to this checking whether left part is present or not, or right part is sorted or not, or left part is sorted or not, right? That's why we are making mid minus 1, not just mid. So if our value is in the left part, then for sure our search space is the left part. If our value is not present in the left part, then for sure we have to discard the left part and make sure that our value of left pointer should point to mid plus 1, because we have to discard the left part and we have to consider the right part only. So in that case, our left pointer will point to mid plus 1. And the same thing, like why we are doing mid plus 1, not mid directly, because we have already checked the mid and mid was not the value. That's why we have to go for mid plus 1. And the same thing we will do in the right part as well. If right part is sorted, then we will check in the range present or not. If present, key is present in that range, then search space will be the right part. If not present, then search space will be our left part, and that will be applied here. So here also we will check whether mid value of array is less than our key, and key should be less than or equal to our right value. If it is so, that means that our our key is present in the right part, and we will make sure that left should be mid plus 1 because we have to discard the left part completely. And in another case, if it is not so, means our range the value is not present, then we have to make that right should be mid minus 1 and we have to exclude the right part. So this will be applied in every time, and we will decrease our search space each and every time, and that's how it is going to take our midpoint at some time when key is going to match. And if value is present there, then for sure it is going to return the index. If value is not present, then we will return minus 1. So this is how the intuition is for this problem and the coding part. Let's compile it and run it. Okay, so our value is present. Let's go with another input. Take this one. Okay, it is passing this also, and let's try to submit. Okay, it got accepted, and yeah. So this was our intuition to solve the problem, and I hope this was helpful to you. Thank you.